Okay, let's try another example where we construct a probability distribution for a random variable. So if you ever been to a casino, there's the game called craps, when they would roll two dice and people would bet on the sum of the dots that facing upward would determine the outcome of the different bet that are placed. So in this case, so let's say that x, our random variable x, to be the sum of the dots facing upward when two dice are rolled. And what we want in this in part A of this question is we want to construct a probability distribution for this random variable, which represent the sum of the dots from the two dice. Now, and then from there, we're going to try to use a probability distribution to answer some question. So let's think about this. How do we figure out the probability distribution for this random variable? Well, we back in chapter 5, we construct a table that would list all of the possible outcome if you roll in two dice. So you roll two dice. So let's recall this question that we did. If you roll two dice, the possible outcome would look something like this. If you put them in a table, it would be like 1, 1, and then 1, 2, and then 1 and 3, and you have 1 and 4, you have 1 and 5, and then 1 and 6. You know, that's 6 different outcomes. Or you could have 2 and 1, or you could have 2, 2, or you could have 2 and 3, 2 and 4, 2 and 5, 2 and 6. That's another 6 outcome. But then those are not all of them, right? We list all of those, and the very last row that you get, you would have like 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. So there's a total, if we have to list all of them, which we did in chapter 5, there's a total of 36 possible outcomes in this probability experiment. When you roll two dice, there's a total of 36 possible outcomes. Now here, we are looking at our random variable, which represents the sum of the two dice. Okay, so here, keep in mind, x represents, x is the sum of the dot facing upwards of two dice. So let's think about, what are the possible value for this x. So we're gonna construct a probability distribution for this again. So that's gonna be, so the probability distribution would have the possible value of x, and the corresponding to each possible value for x is a probability for each of these possible value of x. So you have, if you take a quick look at the table, you can see that the minimum value for x would be 2, because when you add up 1 and 1, that's 2. You cannot get lower than 2. So the lowest value for x would be 2. What's next? Well, you could have 1 and 2. If you roll a 1 and a 2, that would give you, the sum would be 3. So another possible value for x could be 3. But if you draw a 2 and a 1, you have 1, 2, that gives you 3, but 2 and 1 also give you 3. If you could think of this as, let's say one of the dice is, if I write this as one of them is red, right? So this is red, 1. And then the other one could be green, right? 1 and 2, like that. And that would be different from if I have a 2 that is green, right? If I have a 2 that is green, which is the one that I have here. So let's say 2 that's green, and, well, actually a 2 that is red. Let me erase this. If I have a 2 that is red, and a 1 that is green. Okay, and 1 that is green. And then you can see the difference between the two. These are two different outcomes. Okay, that would give us 3. Okay, well, and this goes on. You could have, another one. The next one you could have is your x could be equal to 4, which is when you have drawn a 1 and a 3, or you draw a 3 and a 1, or you draw a 2 and a 2. Right? So that would give you 4. So that would be, your x could also be equal to 4. And then if you look through the entire table, you will see that, well, your x could also be, your x here, the random variable x, could also be equal to 5, or 6, or 7, or 8, or 9, or 10, 11, or 12. So 12 would be the maximum value for x, because that's when you get a 6 and a 6. And you cannot get higher than a 6 and a 6 when you roll 2 dice. So that's 12 would be the maximum value for your x. So now let's think about what is the probability for each of these outcomes that we have here. Well, to get a 2, the only way to get a 2 is both of your dice had to be a 1. You have to come up with a 1 on both of the dice. And there's only one outcome that would give us that, would give us the sum, where the sum is 2.